right, thank you. Thank you, Vincent. And as Vincent just mentioned, I'm going to give you some update on the MyGene and MyVariant. First, I would like to give you some recap about the MyGene and MyVariant.info. As I presented previously, and MyGene and MyVariant.info are aggregated genes and variant annotations, one for gene annotation, another for the variant annotation. We both serve the aggregated annotations as high-performance real-time web services. That's what the MyGene and MyVariant in a nutshell. So, like the really motivation for us to do this is all the gene annotation or variant annotations, just so many resources. They are spread out to all different type of input file, different interface, and so it's really like a lot of work for the bioinformaticians to aggregate everything together for those annotations, especially for the variant annotations. Even more like fragmented, more like more difficulty for the bioinformatician to handle that. And then pretty much like all the people who need those annotations need to repeat all the effort, like download the same flat file and handle the data parsing, and maybe like hit by the same bug or same input file problem, and repeat all this effort. So we would like to develop something, some platform, so that we can at least like we or other contributor of our project can do this data parsing once, and then serve the structured data to the end user using the high performance API. So that's essentially the motivation. And we all know all this annotations are so fundamental, so important for the biological research, and like a gene annotation, variant annotation, and we also have other annotations like around disease, metabolite, and a pathway, also can be like a protein. They are all like linked together, but normally when we organize all the knowledge around those bioentities, we tend to using like those gene-centric or variant-centric or disease-centric annotations. Just like for each gene variant, we have an ID, and then we have all kinds of annotation as attribute to attach to those bioentities. That's essentially how we organize the biological knowledge right now. So in MyGene and MyVariant project, we actually essentially organize the knowledge and like a gene annotation, variant annotation in the same way. So we using a variant annotation as an example. For example, we take the dbSNP, the flat file, and when we parse this into a JSON format using the ID as so-called HGBS nomenclature as a variant ID, and then all the dbSNP annotation we parse out and put it into a structure under the dbSNP subdomain. So like a SNP plus RSID function, those are all dbSNP specific put into this structure. And the same thing we can have the same JSON structure for cosmic, like the tumor size, which is specific for the cosmic. And also for the dbSNP, we have their specific data. And then we can do the same thing for the other data resources like a CAD, Killing Bar, EVS, MuseDB. And all of them, they have their own structure, but we will put all the annotation under their own namespace, but we use the same ID in each JSON object, which allow us to aggregate them together. Like for the same variant, we can aggregate all the annotation from different resources, put them together, and then we can do we can store it in our database and do the indexing, allows people to do the query and retrieve the annotation by their IDs. Okay, so this is basically the slide to show the overall architecture of MyGene or MyVariant. This is a specific example is using the MyVariant.info as the example. So like I talked about, like we have the loading script to convert each flat file into individual JSON document, and then we then can merge them together as one big JSON object per each variant. Then we send this to Elasticsearch as an index engine. And on top of the Elasticsearch, we have built Python using a Tornado-based web front end to build the high-performance, non-blocking, so-called like a web API. And you can see all the N here indicate multiple nodes, so that we can achieve the scalability for the to meet the increased demand for the web API request. So that's how we actually build the backend, all the backend of the MyGene and MyVariant web service. So for the end user, this architecture basically provides a high-performance web service API. This is what a user will use. And for example, for MyVariant.info, we provided the so-called you can do the variant query using any query term, and we use the Elasticsearch to index every attribute in a merged JSON object. So you can do a query like, give me all the variants, like a cosmic says like associated to breast cancer, and maybe CleanVar says like it has some clinical significance associated to this variant. You can do like this simple or complicated variant queries, and you can also retrieve the whole variant object using the so-called HGVS ID. And you can also using a parameter called field to retrieve the subset of the variant object. For example, if you only need the CleanVar, only need the cosmic, you can do that. You don't have to retrieve the whole big variant object. We have a live API in the documentation. If you want to know the more details, you can go to our website and check out the more example in the documentation. Also want to mention both the services actually support the batch mode. So you can do the batch query for like 1,000, even like 10,000 of query at one time. Okay, this is a MyGene.info endpoint. Essentially the same. You can do the query for matching the gene, and you can also do the retrieval of the gene annotation using the gene ID. Here, gene ID can be either NCPI gene ID or ensemble gene ID. And essentially, we provide the same style of documentation, also the batch mode via the post request. Okay, so now I would like to give you some update for the MyGene and MyVariant, how we actually do for the last year, like 2015. When I report previously about the MyGene and MyVariant usage, I normally say we have for MyGene we have over 2 million usage, 2 million requests per month, which is pretty good. And then now when I check this same usage before this presentation, actually just to check the last 3 months, like from October, November, and December of 2015, we have about more than 3 million requests per month right now. This is actually pretty good, pretty solid increase for the MyGene.info usage statistics, and we're happy to announce to share this on our Twitter, and which is like really excited about this, and for the 10 million hits among 3 months. Okay. And this is like another slide I probably showed before. This is like the last. It's actually Christmas in 2014, not last year. And we saw like a 5 million hits a day, like a spike. This is probably just from one particular user. And we didn't see this in last Christmas, which is good. We like our user to really take break. You don't really have to work during the Christmas. But we see the really solid overall usage increase from 2 million per month to 3 million per month, which make us even happier. Okay, so and also we observed that we have the increased client adoption. MyGene.info, MyVariant.info, we both have like a Python client and an R client. They provide some useful and convenient function for users to using our web services. And also from this October to December 2015 usage, we can see the MyGene Python client usage actually now surpasses the BioGPS usage. Like this is a 26% only the traffic from our own application BioGPS, and this 30% is from MyGene Python client. And this is the first time I saw the Python client usage surpass the BioGPS usage now, which is great. And also we saw the 9% of usage from our client, which is nice to see because we last time I reported, I think the R client usage is around like 1%, as we just released the R client like early 2015. Okay, so and then this rest of the 35% is a user who just access our API directly using like a curl, using their programming language. So we are happy to see the increase in client adoption because client provides more how to say, like a more convenient function for user, and also provide a good feature to like prevent like saturating our server. Like for example, if you using client, you can do a query for like 1 million query terms. But internally, client will do the chopping the long list into 1,000 at a time, and then send the 1,000 query terms to our backend server, so it won't saturate our server, which is good. So we do encourage people to using our client if possible. Okay, and so for both MyGene Python client and MyGene R client, we actually do see the increased like downloads from the hosted website. For MyGene, we have now see very stable like 600 to 700 downloads every month. For our client, we released like about 1.5 years, but we already see the downloads is already among 20% among all bioconductor packages right now. That's pretty good to see this ranking. Okay, so now here is what we actually what we have done in 2015 for MyVariant.info project. We now have aggregated like a total 334 million of annotated variants, and we included like exact data. And exact data is a very useful data for the population genetics, like the normal people's allele frequency for the all observed human variants, and also the graph, which provided information about the GWAS association between the SNP and the phenotypes. We included these 2 new data sources, and we also updated dbSNP, CleanBar, CAD, and dbNSP to their latest version. We also have the usage stats for MyVariant.info. We currently have 1 million requests in the same 3 months, which is good comparing, given like this MyVariant.info is still very young, and we formally released just the last year. We already see that like about 30% of the usage will come from our Python client, and right now the 2% that come from our R client. We will see this. We will revisit this usage statistics later and report you any updates. The same for the MyVariant Python client. Right now we achieved like about 500 downloads in the last month, and the MyVariant R package doesn't know any download ranking yet because we just released a few months ago in October. So we will continue monitor those usages. And another thing I think is what makes us really excited and also feel like more awarded is some response, really like a nice response from our user. For example, this one user called Larry Hengel, he actually feel very passionate to create like a Node.js client for MyVariant.info. It's called a MyVariant.js, which is great, and because Node.js now is a very popular platform to build the web applications, And also, you can using this library directly in browser if you want to develop some front end using the MyVariant.info or MyVariant.info web service. If you are interested, you can check out you can install the MyVariant Node.js client directly using the npm tool. So this is very exciting. And just recently, I also noticed that it's actually some user just tweeted us that, okay, I created something called WhoBot for MyGene. What WhoBot is just like it's almost like you talk to a robot. So it's actually a Node.js-based application. Once you install like this, you can basically like talk to a computer. Like you can use like Huber, get the gene symbol 672, then Huber will reply you like a bracket 1. You can do some kind of like a simple interactive communication between the user and the computer. I'm not sure what's a very good use case of that, but it's kind of like pretty cool to see this happening from our user. And we will, we will continue. We will follow up with those users and see, help them to continue develop those, and hopefully there's some cool use case, cool applications can come out of those from our passionate user using our API. Okay, so next I would like to touch on what's our plan for the next, especially like for this year, for MyVariant and MyGene.info. One important target for us is we would like to make our API serve so-called linked data, and specifically we want to do this via so-called JSON-LD technology. Why linked data? Because I have shown you all the existing knowledge is organized around all these bio entities, but they are not isolated. They can be interconnected. For example, gene maybe have one attribute that says like this gene has one disease-causing variant. Then, because in MyGene.info, we are not going to store all the details about this variant. Maybe we'll store the HGVS ID of this variant, but we won't store any detailed information about the variant. And the same thing for the reverse, right? For variant, maybe this will have, this variant occurs on gene BRCA1, but we are not going to store the pathway information or protein domain information for variant in MyVariant.info. Those information exist in MyGene.info. Right? Same thing for the other disease, metabolite, and pathways. And we will see those data can be served from the separate APIs, but they are also kind of linked to each other because the underlying underlying biology. So we would like to make all this API able to link together, able to do the query across those APIs, and then which will help us doing the a data aggregation, and also help the people to discover the different other APIs. So the one particular use case I would like to show you is for example, we have MyVariant.info, and we also talked to another collaborator. They probably have another variant API, and they have some common. We have some common annotations, like a gene, which transcript is type of a variant, and it is a disease causing. But they have their API probably have some of their own specific data, this specific collaborator, they actually have the allele frequency in some specific population genetics study, which we don't have. But our API actually have a clean bar, has a cosmic, which they don't provide. So hopefully we can have some mechanism to aggregate all those two API, merge them into a single variant. Either for user, you probably want to do this on the fly. For MyVariant.info, we probably want to do this on the back end in a batch. Maybe regularly we can pull the information from this API, aggregate it into MyVariant.info so that we can serve the same data, all the data together to our end user. So both use cases, either on the fly or on the in a batch mode, should be useful if we can do if we have some generic way to aggregate this type of data. Okay, so this is probably like a more realistic example. Like this is my MyVariant.info variant object, and this is another API. Those green are the specific data we want to bring into MyVariant.info. Ideally, we will have another new namespace called new data source, and then we put this information, merge it to the same variant for this one. So we would like to explore the way of using JSON-LD to help this aggregation process. This is how we actually did. So what so-called JSON-LD is just the JSON our original JSON object plus some context. So this real example is to show you what we actually add is just something called add context. Those are like a special key name with some mapping about your about the key name in my object. For example, like this clean bar. This is actually called data source in MyVariant.info. So we have a clean bar here, and under the clean bar you can see another level of context defining what's all the attributes under clean bar. For example, we have arming under clean bar. There's arming. This is arming ID. Then we will tell, okay, this arming attribute is actually the arming identifiers. You can see here we using a so-called identifiers.org UI. This is a project done by EBI. They provide a very nice, unique, stable UI for a lot of commonly used identifiers. And I think here it serves a perfect use case for MyVariant.info JSON-LD context. We just mark this arming ID is this arming identifier. And same thing, we can label this symbol as this symbol HEF are the human HGNC symbol. And this RCV accession number is actually the clean bar accession number. So you can see what we actually do using the context is basically just do the mapping, right? So now, once we provide those extra contexts to the original JSON object, then we can do some magic thing using the JSON-LD processor. One output is called like a JSON-LD compact output. So after we process the previous this whole JSON-LD context, we can gather the result like this. So this is a compact output. So you can see that the output will look like we don't have any any arbitrary key name like arming, symbol, or clean bar, and we now have replaced the key name as like using the UI. So it's a stable UI, and the value keeps the same. And you can also see that anything else, other attributes we didn't mark in the context, they are done. Only those attributes we marked in the context they were left here. So this gives the end user easier to consume this and in a more stable way, because no matter how I define my key values in this output, this key will always be this UI. And assume and people will agree using the same UI, then you can access the value using some stable UI. And also another output format called nquartz. This is even more normalized output. In this output, you can see even all the JSON structure has been broken into a flat list. So you can see here, this is the arming ID, and this is arming, this is the value, and this is the symbol, this is the value, this is clean bar ID, and this is RCV ID. That's it. So this actually gives the end user very easy way to generating the flat list of the output, and so that you can easily retrieve give me all the clean bar ID associated to this particular variant. So very easy to parse, and regardless of how the API developer how to organize their data structure and how to name their key in the JSON object. So yeah, here's just a summary. In a nutshell, the JSON-LD is basically marks value in JSON object to define the UI, like a clean var accession marked to this clean var UI. Okay, so far we have seen the like a JSON-LD context can make the data actually essentially I call it like a linkable, but if I provide a JSON-LD for MyVariant.info, another collaborator provide a JSON-LD for their API, that doesn't really make our data automatically connected. We still need some kind of like a downstream processing library to actually make this happen, link both data together. So this is what we actually focus on right now, and try to develop some kind of like a downstream processing library to handle the data integration. So this work is mostly done by a graduate student in our team called Kevin Shin. He already developed some library and some basically like a helper function to do this kind of integration. And I would like to show you one example is like here. There's one function called fetch value source for variant. What this one is doing is like given a variant, give me all the data, like say dbSNP ID for this variant. Then you can provide the URI for dbSNP, like from this identifiers.org this UI. Then it will gather all the information, gather the variant object from the MyVariant.info and list all the RSID provided from the MyVariant.info for this particular variant. For example, like this is all the RSID from dbNSP, from CleanVar, from dbSNP, from EVS, GVAR-SNP, and the MuteDB. Of course, for the dbSNP, we can see all these values are the same. But we can see like, for example, we can get like polyphon score or polyphon prediction. Sometimes we do see some discrepancy from the different sources. Maybe some say like damaging, another maybe say deny or something. And that's actually provide an easy way for us to validate our data, and also for the end user, they have an easy way to retrieve the one particular data for a given variant, so that they can use it in their downstream application. And for us, this actually provides a way to, for example, if we want to aggregate the population genetics from another API, we can just routinely run this and just generate a flat list of the population genetic, like allele frequency for each variant, and then by parsing this flat list, we can get the result back to merge it into MyVariant.info. Provide us a very generic and stable way to integrate this data. Okay. And then I think another direction for us is really we want to define some kind of like an API spec, because in order to do this integration, we do require the API follow some kind of either guideline or standard. At least the API should provide some minimum feature in order for those the JSON-LD based integration works, both on the fly or with in like a batched mode. So I started to document this, and I'm preparing this, and eventually I will post it on like a GitHub as a guideline for the developing, especially like a BioThings entity-based APIs. And here's just a few guidelines in my mind. So first, of course, like output must be a JSON. That's like a very straightforward with a defined ID. And second, you basically need to provide some kind of like a toggle to toggle the JSON-LD context, because for a lot of users, actually, they don't really need to use in the JSON-LD. And what JSON-LD nice about it is it's totally optional. you don't have to mark all the attributes at once. You can just mark anything you actually need to be marked in the context. It doesn't change the existing JSON structure. This is nice. And also the third one is the support retrieval of a single entity via GET. And that's very straightforward, because once you have an ID defined for each object, you should be able to get back this object via this ID. And like a use case is like people can do the on-the-fly aggregation for one particular object, right? And also need to support retrieval a list of entity via post. That's like a more for the use case, like I need to do some routine data aggregation in a batch. So, and another one is like output should indicate the entity existence. For example, if I give like the ID exists in my database, but I want to know that this actually exists in your database. Ideally, if we can get back like a full code, then we know, okay, this does not exist for you. And I like to see like all the API implement this, return some standard 404 status code instead of just return some error message. Because those error messages can be arbitrary. It's hard to tell, how to have like some generic way to tell whether this is exists or not. And also, we would like to do like in the batch mode, if there's some unknown ID, and it's better to have some kind of a way to indicate that this ID is not found instead of just ignore this ID in the output. This is actually oftentimes I see this from the other API. So it's always better to list all the input in the result and then indicate which is exist, which is not. So that's always a good practice. Okay, so next thing I would like to touch on is called like a BioThings API. And this is also something like when we develop the MyVariant.info and MyGene.info, we start to gain the experience about how to make a high performance, reuseful API for the end user. Then we start to think about like really like between MyGene and MyVariant.info, there are a lot of things are shared common. They are common between the two. And for example, they are JSON data have a JSON-based data aggregation mechanism, and they both provide a high-performance query engine. We can also do like a JSON-LD enable to link the data, and also like a well-designed like a REST, very similar REST API pattern, and this plus like a data updating scheduler, Python, and R client. So really, those are very generic. It's not specific for gene, for variant. So we start to think about maybe we can abstract this, apply it to other by entity, like a pathway and like a disease, and metabolize all this. And then more important, I think we want to provide something to help other people to host or like host their own API for their own specific data. We can see this like right now is like very trending for people to provide this web API, and we would like to provide a framework to help the people to make this happen. Okay, so one thing we got from the last all hands meeting, especially during the API working group discussion, we can see like a lot of people want to create the web API right now. To share this data, and actually making a single web API, web service is pretty trivial right now, and because you can do like even with the CGI as like a single any kind of like a web service will provide the web framework you can build upon to provide some kind of like a web API. But if you really want to make some like a sustainable, scalable web API, it's actually non-trivial. You probably need to involve like managing multiple multiple nodes to build some kind of a cluster, and so that your server won't crash if there's increase the bandwidth request. Okay, so that's why we want to help other groups to create their own hosted API. to sharing the data. One thing is one action item from the discussion actually is creating the so-called web API, BioThings API white paper. This is essentially what I mentioned, like the API guideline, and this is something I'm preparing, and hopefully will come up pretty soon. And another action item is we want to start to creating some called like a BioThings API framework. Really, like from the all hands meeting, we know the NIH comment is going to be like some kind of like a cloud-based infrastructure using either Amazon or like a Google or Microsoft cloud infrastructure. They provide a very nice way for you to like abstract the server management. They provide something so-called infrastructure as a service. But what we want to provide is like for the BioThings API is so-called like software as a service, something provide on top of the like cloud service. People can use this framework to build the additional web applications, web software. So again, then another third action item for us is we want to using the BioThings API framework to extract to expand to like drugs, disease. That's at least something we are just started to build and want to as a proof of concept for the generic BioThings API framework. And oh yeah, yes, I just want to mention we actually just checked the domain name. Actually, MyGene.info is not available. We probably need to find a alternative name for us. Okay, so I think I will just finish here, and I think I would like I touched on the MyGene and MyVariant project update, and I showed you the JSON-LD use case and for MyVariant.info API, and also just to share with you our plan about the BioThings API framework. And I would like to thank our team, and especially like Kevin, also Jiwen Xing, who really focus on the MyVariant.info and the JSON-LD integration. And Cyrus is mostly focused on the MyVariant.info project plus the BioThings API right now. And also the Ginger, Adam, and also Greg and the team from our group for their contribution. And also our collaborator from different institute. Yeah, okay. I will stop here. If there's any question, I'd be happy to answer. Thank you.